Okay, welcome, Mar. Welcome, Robert. Thanks for showing up, and hopefully we'll get a couple more. This week is the week on the central limit theorem, which is the most important theorem in statistics, it turns out. And it's in terms of content, it's not the longest week. That's the good news. I tend to go really fast at the beginning and then start slowing down a bit. But I want to make an important announcement, and that is your online exam is this week. So you have to do your online exam by the end of the week, and that can be done by Sunday. But expect it to be a lot longer than just a regular assignment. And you also have regular assignments. The online exam covers chapters 1 through 5, I believe, something like that. So you definitely need to get that figured out. Let me double check. So expect it to take a long time because it's a bunch of problems. In fact, I'm going to click it now to tell you how many because it's a lot. I think 50. Yeah, there are 50 questions on it. Okay, so you definitely need to be able to handle 50 questions. Okay, and yeah, it's 1 through 6, I believe. Okay, are there any questions from either of you? Any questions? Feel free to talk. You got to click the mute button if you have questions, though. Okay, if there's no questions, just a note, I just finished grading the project one. Most of them are pretty good. The biggest issue that happened, but I don't think it happened with either of you, but still happened to those who might be watching, is a few didn't get a partner. And that was not successful. So if you don't have a partner, if you don't have a partner for project one, you need to get one for project two, or it's never good. So having a partner is absolutely essential. Those who did have partners, pretty much, I think all of you got A's and B's. There might have been one C, but the projects were good. You want to open up the project and take a look at my comments. And I'm only able to put the comments on the paper itself, and only the person who submitted that paper can see those comments. So if you're the one that submitted, make sure that you share the comments that were directly on the paper with your partner so that they can actually see the comments also. That's really important. So any questions before we move forward? Okay, let me talk about the central limit theorem. Again, I don't give you all the details in the webinar. I give you example problems. So I'm not going to do the full theory, but I'm going to kind of quickly talk about it, and then we'll do examples. I even have one that's a print event example. The main thing in chapter 6, we talked about the normal distribution. And in chapter 6, you really don't have any reason to believe that the normal distribution is that important, because it's just some distribution. Chapter 7 is where we find out the normal distribution is important. And if you remember the project, I told you had to have over 30 as a sample size. And it turns out that if you have over 30 as your sample size for a quantitative sample, then the sampling distribution is always approximately normal. So that's really powerful, because if you don't know the distribution, you can't find the probabilities, because there is no CDF function on your calculator. There's only normal CDF and a couple others. So the good news is that if you have a large enough sample, you can work with the normal distribution. Any questions? Mike, it's just you now. We'll see if Robert comes back. So don't forget to talk, because right now you're the only one. I'm not sure. Maybe it's a bad day. I'm not sure what's going on. You might know better.
I don't know.
Yeah. Are you one of those from Modesto?
Yeah.
Yeah, I know that. Did you have finals last week or something?
Yeah, our spring semester ended a few weeks ago.
Yeah, so it might have something to do with that. But I want to remind everyone who's watching this as an archive, please post when you want this to be, because I can change the times so that I can make it a time that you want. So for next week, for example. But at least you're here. My quorum is 1. So don't leave or then we kill the whole thing. So anyhow, it turns out that if you have a large enough sample, then we can always get a normal distribution. It's not the distribution of the population. It's not the distribution of the sample. What it is if you look at all possible samples and you look at the mean of those samples, and then you consider the mean of the samples as the data values, then those data values, those means, sample means, will be approximately normally distributed. And that's the big deal with the central limit theorem, is you get this normal distribution because we're looking at means of samples. Okay, and you get a little more than that, even if you don't have a large sample. For the large sample, over 30, you get the normal distribution. For any sample, the sampling distribution's mean will be the same as the population mean. And the standard deviation of the sampling distribution, which we call the standard error when we're dealing with that, will be the original standard deviation of the population divided by the square root of the sample size. And the big deal about that is if you have a large sample size, then you look at the original standard deviation divided by that large sample size. Let's say the sample size is 100. The square root of 100, hopefully you know, is 10, right? So if you divide by 10, you get a much smaller standard error than your original standard deviation. And what the standard error tells you is how likely the sample mean will be to the population mean. Because remember, standard deviation measures spread of data. So if you randomly select a data value and you have a large standard deviation, then that data value could be really far from the mean. If you have a really small standard deviation, then that data value is going to be close to the mean. And here your data value is a sample mean. So what it says is if you take a sample and you have a large sample size, then it's very likely that that sample mean will be close to the population mean. Dominique, thanks for coming. There's just 3 of us right now. But I was just going over the central limit theorem. And then we'll do some examples. So again, you always want a small standard error because that means that you have good information about the population. Because remember that in the real world, you can't get the entire population. What you do is you take a sample and you use that sample to make an educated guess about the population. Okay, and in particular, the population mean. If your sample size is large, then you have a really good educated guess. If your sample size is small, your educated guess is not that good. Any questions on that idea? Okay, so I think what I need to do is do an example. Otherwise, it's a bunch of theory. And theory is kind of hard to get without examples. So let me do an example. Robert, you're back. You left and came back, which is good. We got 4 of you now. So let's do an example. And let me pop it in. And that is... What is it? There it is. Okay, and let me pop my example up. All right, so here's the question. Suppose that the number of hours per month that college students volunteer is normally distributed with mean 2.8 and standard deviation 6.7. For the following questions, do the following. Write down the indicated distribution, sketch the appropriate diagram, answer the question, and state whether the normality assumption is needed. So I want to let you know something really important, and that is on the midterm. This part that says write down the indicated distribution, sketch the appropriate diagram, answer the question, and state whether the normality assumption is needed, you will be asked to do that. That's a guarantee. I ask that on every one of my statistics tests. Okay? It won't be a question about college students volunteering, but that's not the hard part. The hard part is to know what to do. So follow along, take good notes, because you're going to have to do what I'm doing. Okay? So let's look at part A. If a college student is selected at random, what's the probability that the student volunteers at least 5 hours per month? So notice here, it's just one student. Is that clear? Because it's one student, we're not talking about samples, and we are in the context of chapter 6. Okay, this is just a normal distribution question. Find the probability. So the first thing you need to do, and I forgot to check the chat box. Let me do that, just in case anyone has questions. The first thing you need to do is to, as it says, write down the indicated distribution. So in this case, because we just have a single individual, there's nothing fancy going on, the variable we use is x. Except that's way too big. How about that? Still a little too big. So we're going to use x and then tilde. Remember seeing that in a chapter 2 ago? And then tilde, the distribution is normal, so it needs the letter n. And then you put the mean and the standard deviation in order. 2.8, comma 6.7. Any questions on that? Okay, I've now answered the first part of part A. Okay, part B is sketch the diagram. So for this one, the shape of the curve is normal. So hopefully you all know how to draw a normal curve. So I'm going to go ahead and do a little normal curve. Like so. We know that the mean is 2.8. That's right there. And we want to find the probability that the person volunteers at least 5 hours per month. So is at least left or right? What do you think?
Right. To the right?
Yeah, at least is the right. Okay. A lot of people go too fast and they make that mistake and they go the opposite direction. So it's really important you don't want to go backwards. So that means I'm going to shade in to the right. Any questions so far? Okay, the next thing I need to do is I need to answer the question, because that's the third part. So to answer the question, I need my calculator. So let me share my desktop with the calculator. And let's clear whatever used to be there. And then I go normal CDF. So it's going to be second distribution Number 2 is normal CDF. The low is, find again, 5. The high is a bunch of 9s because we're going all the way to the right. The mean was 2.8. And the standard deviation, sigma, was 6.7. And there I have it. It's about 0.37. Any questions on that? Okay, let me reshare. The last thing I have to do is state whether the normality assumption is needed. A lot of people I've learned don't know what the word assumption means. Can anyone tell me what it means?
To think something without knowing for sure.
Yeah. It means we don't know it. We can't conclude it. So we just have to say it's true even though we don't know. In fact, the way I like to remember it, what's the first 3 letters of the word assumption? Exactly. Okay, so you don't want to have to do it because that's what you're going to make out of yourself. So but in this case, we don't have any theorem that says that we have a normal distribution. All we have is the assumption. So it said we're going to assume that it's normally distributed. So that assumption was necessary. You can't just, if you erase this normally distributed here, you can't answer this question. Is that clear? So the assumption was needed. Let me type this out. Since we just are looking at one individual. Any questions on that? Okay, so that's part A. Let's go to part B. Part B is if 55 students are selected at random, what is the probability that they average between 3 and 4 volunteer hours per month? Okay, this is a very different question. And I want to underline the key word here. And the key word is average. So we're not looking to see what is the probability that a person has a certain number of hours. We're looking to find what is the probability that the average is a certain number of hours. Does that make sense? So because of that, we're looking at averages. What is the symbol we use for averages if we're looking at a sample? You guys remember? What symbol do we use to represent the average of a sample?
Is it X bar?
Yeah, it's X bar. So notice in part A, we had X tilde N. Do you see that? For part B, we're not going to have X, we're going to have X bar. Any questions on that? Okay, then we can do the rest using the central limit theorem. So we can write tilde N. Now the mean of the sampling distribution is always the same as the population mean. So the population mean was 2.8. The mean of the sampling distribution is also 2.8. Is that clear? That's the big theorem. The standard deviation of the sampling distribution is not the same. Do you remember how to do the standard deviation of the sampling distribution? I mentioned it pretty quickly. Remember, you take the standard deviation and divide by the square root of the sample size. So that's really important. And the standard deviation was 6.7. Then we divide by the square root of the sample size. The sample size is 55.
And what is that value? The standard deviation of the sample size?
Yeah.
Okay.
No, standard deviation of the sampling distribution.
Oh, sampling distribution. Okay.
Yeah. The sample size is just 55. It doesn't have a standard deviation, it's just a number. But the sampling distribution is all the possible sample means that you can get from this population if you have samples of size 55. Okay, so you can ask 55 college students at your college. You could ask 55 college students at my college, right? Right, which might be your college. It is your college. Let's say you could ask 55 college students at LTCC. You could ask 55 college students at UCLA. You could watch 55 college students in, all over the place. And there are billions and billions of different groups of 55. Do you agree with that? Each of the groups has a sample mean. If you take those sample means, put them on a histogram, you're going to see a distribution. That's going to be approximately normally distributed, and it'll have mean 2.8 and standard deviation 6.7 over root 55. So it's always a long story. You just can't explain the sampling distribution in just a few words. So if you want me to show you the shortened version, there is none. Okay, you have to think about all the different possible samples of size 55. Look at the means of those samples. Think of those means as your new data set. And then you can look at the mean of those and the standard deviation of those. And that's what we get, 2.8 and 6.7 over root 55. Any questions on that? Okay, so the good news is our picture starts out the same because the mean is 2.8. So let us do that. Any questions on that so far? We want to see if the average is between 3 and 4. So let's put a 3 and a 4. Any questions on that? Okay, I'm going to ask you to put something in the chat box. I want all of you to do it. I want you to promise me you'll remember to divide by the square root of the sample size when it's a probability about averages. I want you to say, I promise, in your chat box. There's a reason I'm making you do this. And I hope you'll never go back on your promise. And I'm not sure if Kim is there. I see her wall. I don't see her picture. The reason I'm doing this is when I give the test, and I always put on the midterm, I always put on the final, more than half forget to divide by the square root of the sample size. Okay? So you've now promised, and you don't go back on promises, right? So don't forget that. Don't give trick questions. That word average will be there. You just have to look. You just have to see it. Does that make sense? So don't forget, because if you remember to do that, and you remember to put the X bar, just about everyone gets the question right. But those who forget never get it right. just to let you know. Okay, so now it's calculator work. And kind of, I don't know, busy work, but let's go do it. And so I do not stop share, I want to new share. Okay, so what we're going to do is we're going to go second. We are going to go distribution, normal CDF. And I want to remind you, if you have the older version of the TI-84 or if you have a TI-83, it's going to look a little different. Then you actually have to type it in with commas. There won't be a menu. Okay, and the lower was 3. The upper was 4. The mean was still 2.8. And now the standard deviation is not 6.7 anymore. It's 6.7 divided by the square root of the sample size. And the sample size was 55. And what I like about the calculator is you can put it directly in. You don't have to like first find the square root of 55 and then do an estimate with decimals. You can just type in the square root of 55. And I hit enter, and enter one more time. So there's about a 32% chance. Any questions on this? Any questions? Okay, so let me do new share. All right. Now the last piece, and this is the other thing I want you to promise, and that is don't forget to answer the question. What I recommend doing when you're doing on the midterm especially is the following. Next to this, write down 1. Oops, won't let me do 1. Ah, I know what the problem is. One more try. So next to that, 1. Next to the picture, 2. Ah, one more try. Next to the answer, which we got, which was 0.37. Let's do it here, actually. Three. And next to this one, the normality assumption, 4. The reason I recommend it is that way you'll remember to do all 4 things I ask. And I told you it's going to be on the test, so if you remember to put those numbers in, then you'll be able to answer the questions. Okay, and you won't forget one of them. And I'm saying this because about 40% forget at least one of the 4 things I ask. Okay, and I don't hide it or anything. It's all here. I tell you you're going to have to do 4 things. And I don't quite understand why people still forget, but they still forget. Any questions on that? Okay, so what is the 4th thing? The 4th is, was the normality assumption needed for part B? What do you guys think? So was a normality assumption needed for part B? Any thoughts? Not seeing y'all jump in. Look at the sample size. The sample size is 55. And what's an important thing about the number 55? Not sure. It's greater than 30. So if the sample size is greater than 30, then the central limit theorem guarantees that the distribution will be approximately normal. You don't need to make an assumption. And that's like a main point of the central limit theorem, is it allows us to not have to assume that the distribution is normal, because assuming is always bad. So the normality assumption is not needed. Since the sample size is 55, which is greater than 30. Any questions on that? Any questions? Okay, I'm going to erase some of this stuff because I'm out of space, so I can do part C. So speak now, or you're going to lose it because I'm going to erase it. Got it. Okay, the third one is find the IQR for the sum of 15 randomly selected college students' volunteer hours. So the first thing is, do you remember from your algebra class, hopefully I didn't just say a bad word, what the symbol is for sum? For a sum of a bunch of things. If you remember? If you don't, I'll show you. Okay, so the symbol for sum is that. Does that ring a bell? Okay. The interesting thing is that's sigma. Turns out we have sigma for standard deviation, sigma for sum, but it's Greek, and just like in English, we have capital letters and lowercase. This is capital sigma. And the standard deviation little thingy is lowercase sigma. So we're going to go sigma x, because it's the sum of the x's. And then tilde. And then we can look to see how you get the distribution. So first thing, normal. So since it's normal, I can write n. Now the mean will not be 2.8. If you're talking about the sum, if you think about it, if you're looking at the sum of 15 students' volunteer hours, you don't expect that sum to be 2.8. Does that make sense? You're adding everybody up. Of course you're going to expect the sum to be a lot bigger than the average of one person. What you actually expect the sum to be is 2.8 times 15. So it's the average times the number of people in the group is what you would expect the total average is, or the average is a sum. So that's 2.8, and I'll use the star for times 15. Any questions on that? Okay, then we need the standard deviation, and there's a formula for that, and that's going to be 6.7. Instead of dividing by the square root of the sample size, you multiply it by it. So I think I need a brush for square root. And the reason for that is some algebra that my guess is some of you might have forgotten. And that is, if you take 1 over the square root of n and multiply it by n, you get the square root of n. Any of you remember your algebra? Maybe not. But that happened in your algebra class, maybe way back when. I don't know when you last took algebra, but it happened. So the square root of n over n, n over the square root of n is the square root of n. So in this case, n is 15, so it's 6.7 times the square root of 15. And I guess I should close that parenthesis. Any questions on that? Okay, just a note, 2.8 times 15 is 42. You can stick it in a calculator, you can trust me, whatever you want, but it's 42. So that means that when we draw the normal distribution, our mean will not be at 2.8, our mean is going to be at 42. And I'll let you know, more than half of the class typically doesn't get that. They draw it wrong. So don't draw it wrong. Don't be that bad more than half. Be good less than half. Okay, or maybe we'll have a really good class and you'll all get it right. That'd be even better. So hopefully you get it right. So now I'm going to sketch the normal curve. And our mean was 42. And we want to find out what the IQR is. Do you remember what IQR is? Remember what that is called? You should know because you just turned in your projects, which I graded today. And most of you understood IQR.
Q3 minus Q1.
Yeah, it's Q3 minus Q1. So we need to find Q3 and Q1. Q1 is the value such that 25% of the data, or the area, is to the left of that value. So what I can say is that that area is 0.25. And that value will be Q1. Oops. One more try. Any questions so far? Okay, Q3 similarly. Let me just change the color because I think it'll be confusing if I use the same color. One more try. Just have to draw the picture. So now we say the area to the left of Q3 is 0.75. So there's our picture. Any questions about the diagram here? Any questions? Okay, well, how do you, if you know the area, how do you find the value of x? Or in this case, the value of sigma x on your calculator?
Inverse.
Yeah, this is going to be the inv norm, the inverse norm. So now I'm going to reshare and go to my calculator. And I need to go to second distribution. Now we're doing inv norm. And doesn't matter which one you do first, so maybe I'll do 0.25 first. The mean was 42, if you remember. The standard deviation was 6.7 times the square root of 15. And then we hit enter. Okay, and that's about 24.49, etc., or 24.5. And here's a little trick. Let's see if it works. Some calculators it works, some doesn't. I haven't tried this one yet. If I go in and I hit second entry, then it'll just copy what I just did. And I can just change that 0.25 to a 0.75. Isn't that nice? You don't have to do it that way, but it's a lot faster. Then I hit enter. So then I know that the IQR is the difference between the two, 15.5 minus 24.5. 59.5 times 24 minus 24.5, which is 35. Or if you want, just 59.5 minus 24.5, and there's your 35. So the IQR is 35. Any questions so far?
Wait, so why is the mean different for this question?
Can you talk a little louder? I can't hear you.
Yeah. Why is the mean different just because of the sum of 15?
Yeah. So the idea, think about it. If you're gonna take the sum of all the people's volunteer hours, you don't expect it to be 2.8, do you? You expect it to be pretty high, right?
Mm-hmm.
Because you got 15 different people all contributing, and you're totaling the volunteer hours. So that's why you multiply by 15. Does that make sense?
Okay, yeah.
I mean, you could just memorize the formula, but there's actually a really rational reason for it.
Okay, so it's the mean times
The sample size.
sample size. Okay.
It's the mean times the sample size. Okay, and again, the standard deviation is the standard deviation of the sampling distribution times the sample size. But you have to do some algebra to get to where I got. So it might be easier just to remember it. I mean, to put in a note card. Remember, you get a note card on tests. But this 2.8 times 15, that one should be logical, right? That you're going to have to multiply by 15 to get the total. Right? If you average $100 a day at work and you work for 5 days, how much money do you think you're going to make at the end of the week? $500, right? You just multiplied 100 times 5. It's the same thing. Okay. Oops, I accidentally drew something. Let's get rid of that. Okay, so the last thing I need to do is decide whether we needed the normality assumption. What do you guys think?
Yes.
Yeah, and how come?
15 is less than 30.
Exactly. Since 15 is less than, it's actually less than 31, or you can say less than or equal to 30. You have to be bigger than 30 to have this normality assumption. So it's less than 31. The normality assumption was necessary. I want to give you a note for when you leave this class and talk to other people. This book, and I'd say about 2/3 of the book uses 30 as the cutoff line. Some books use 25, but most use 30. 30 is not a magic number, but we need a number to use for our class. So you're never perfectly normal. If you're over 30, you're pretty normal. It's going to look pretty bell-shaped. If you're over 100, you're going to look very bell-shaped. Does that make sense? And your error is going to be much smaller. If you're at 10, forget it. Don't even think about doing these kind of statistics with a sample size of 10. In fact, something that I offer to all my students is that if you get into your master's program or whatever, and you have a question about statistics, or you're doing your research and you need help for your research, then once you're my student, you're always my student, and you can always come back for help and send me an email, even though it's 5 years from now or whatever. I'll be happy to help, but I want to warn you, you may end up crying. That happens sometimes. Because a lot of people do a lot of work, they get a sample size of 10, they think they have something good, and I let them know that you have a sample size of 10, and you can't do this. Does that make sense? Okay, and then I say, you need to get more in your sample, and they always say, but my research is due next week, and I don't have time, and it's like, well, then your statistics isn't very good. So, sample size needs to be large. Any questions on this? Okay, I want to do a current event now. So let me stop the share for now, and let me go find it. Okay, so I like to use Gallup just because they give you all the data, and then all the news stations use Gallup. They just don't bother doing all the data. They just have a headline. Okay, but let's look at it and we can understand it. So half of Americans approve of strikes on Syria, according to Gallup. So the first thing is, do they know that exactly half of all Americans approve of strikes on Syria? No. How do I know for sure, and you probably know for sure also, that they don't know? I absolutely know they don't know about all Americans. Do you know why I don't know? Do you know why I know for sure?
You were not.
They didn't ask me. Right? So how would they know all Americans if they didn't ask me, right? So then the big question is they say half, they say 50%. So the question is, how close do you think it is to 50% for all Americans? Does that make sense? So what we want to do is we want to investigate how good an estimate this 50% is. Does that make sense? So if you want to estimate how good this is, you want to get an idea of how good this 50% is, what you need is the standard error. You need the standard deviation because you want to say that amongst all possible groups that they could have surveyed, are the group averages spread out, or are they all really close to 50%? And if they're all really close to 50%, then you can say that it may not be exactly 50%, but it's going to be close to 50%. On the other hand, if it's spread out all over the place, then you say this 50% is just like some stupid guess that's may not even be close to reality. Does that make sense? Okay, and that's the purpose of the central limit theorem. Okay, so we're going to need one more piece of data. And it's always towards the bottom. And it says results of the Gallup poll are based on telephone interviews with a random sample of 1,511 adults. So we need that. In fact, I think I'm going to write that down, so I don't forget. I can remember 50%. And we call that N, right? All right, so now what we want to say is that, was this sample large enough? So here's the danger. This is a very different question than the one we did before. And the reason is the survey question is what? What do you think their survey question is?
Do you approve of strikes on Syria?
Yeah, and what do you think someone's going to answer? What are the possible answers?
Yes and no.
Yes and no. Whereas in the last question, it was how many hours do you volunteer? And the answer is a number. So now we're dealing with the yes-no question before we were dealing with the quantitative. It changes everything in terms of sample size. So get that in your head. Every single question for the rest of this entire course, the first thing you want to do is say, is this a yes or no survey question? Or is this a quantitative survey question? Is that clear? And this is clearly a yes or no survey question. Any questions on that?
What if it's like a qualitative survey question, but it's not yes or no?
Then you have to be patient, and that's chapter 11.
Oh.
So we'll get there. So we'll have a way of dealing with that, but it's a different chapter. I don't want to talk about that today, if that's okay. But I promise we'll get to it. We'll get to it. We just do one chapter on that. But yes, no happens a lot, right? In terms of surveys and studies. So you want to be able to handle it. All right, so let me go back and let's do the work. So I'm now going to erase everything. And I'm going to write the things we know. So what we know that n is equal to, I wrote it down, 1511. Gallup told us that. Is that clear? Okay, the other thing we know is we're going to say P. For now, we'll just call it P, even though technically it isn't, is equal to 0.5. Typically, this is a population mean. We don't have it, so we're just going to be using the 0.5. All right, so for sample size, to make it big enough, you must, let's write this in red. For the yes-no question, you must have NP greater than 5 and N times Q, and we haven't done Q yet, so let me tell you what Q is. That's N times 1 minus P greater than 5 also. Any questions on that? Okay, so in our case, NP is equal to 1,511 times 0.5. Is that clear? Which is 755.5, I believe, if I did my head right. Any questions on that? And that is certainly greater than 5. So far, Gallup did the right thing. But we also need NQ to be greater than 5. But that is the same number, actually, because 1 minus 0.5 is still 0.5. That's just a coincidence. Normally, you're going to get a different number than 0.5, and you got to subtract. Okay, so this is a little different. This means that we can use the normal distribution. So the distribution, the sampling distribution, let's write it out. Let me just write down the sampling distribution. Is approximately normal. And we can say that because we have NP and NQ both greater than 5. So here's another big warning. I always like to know when, let you know the #1 mistakes that people make. And one of the top 5 mistakes people make on the midterm and the final is not paying attention to yes, no question versus quantitative question, and try to compare with the number 30 when it's a yes, no question. So please don't do that. You don't want to lose points. I don't want to take off points from your test. So don't make that mistake. You always want to look to see, is this a yes, no question? If it is, stick that number 5 on your forehead and just don't let the number 30 come out of your pen. Does that make sense? So just a note. Okay, no trick questions, but you need to know this. All right, so now what we can say is the following. Okay, the first thing is we're going to have the distribution. And we don't use, it's interesting, we have P, and we use P, whereas that's the population proportion, whereas for the mean, we use Greek letters. Greek letters don't work well for proportions. Guys, do you all know the Greek letter for P? You do. It's pi. And that is confusing as hell if you try to use that for anything other than 3.14, etc., right? So we don't use the convention of Greek letters for population. So when you're talking about proportions, P is the population proportion. And the sample proportion is we take P and we put a little hat on top of it. And the formal way of saying that is P hat. That's the sample proportion. So the sample proportion now, we can say is, and you're used to this, tilde n, we could say n because we had NP and NQ greater than 5. So it's normally distributed. The mean is going to be n times p. So that's 755.5. We already did the work, so you might as well just write it down. The standard deviation is a little more complicated. Is the square root of PQ over N. So P was 0.5, Q was 0.5, and N in this case was 1511. Any questions on that? Okay, so just a note, I'm going to do the quick calculation. If you take the square root of 0.5 times 0.5, I know you can't see it, but you can stick it in a calculator too, like I'm doing, divided by 1511. You get about 0.013. Okay, so we're looking at about a 1% difference. So what do you think? When Gallup said that 50% of Americans think that it's okay to strike Syria, is that number 50% pretty close to the true percent of all Americans? What do you think? Yeah, if the standard deviation is 1%, then that means you're only off by a few percent. Is that clear? Because remember the standard deviation. If you take, say, 3 standard deviations, that's going to be 99.7% chance of that happening within. Does that make sense? So that would be like 47% to 53%. So that 50% is pretty accurate. So at first I said, well, I don't know if it's 50%, which is true. I don't know if it's 50%. But what I do know is that it's very likely that it's going to be very close to 50% because the standard error is so small. Any questions on that? Any questions on how the central limit theorem for proportions helps you understand whether you have really good data and a good educated guess, or whether you're just could be way off? Is that clear to all of you? Okay. So the bottom line, by the way, is you want to make sure that you have a sample size around 1,000 or so to have really good numbers for proportions. So the bad news is that's a lot of work. It's the main reason why I don't let you use yes/no questions on your projects, for project 2, for example. Because if I did that, you would have to get over 1,000 data values. And I don't want to do that to you. I'm not that mean. Okay, that you do in, like, if you're getting paid a lot of money and that's your job. But you don't do that as a student. I don't think that's fair. But to ask you to collect 31 data values, that's not too bad. Hopefully you agree. Any questions about how this works? And if we wanted some probability, that the probability was, say, between 750 and 760, then you do the same normal curve thing, and you have your mean and standard deviation, which we just found. And hopefully you know how to do that. You'll be asked to do that with proportions, but basically I've set you up for it. Because once you know the mean and standard deviation, then it's just calculated work. Do you agree? Yeah, then it's just drawing a picture, put it in the calculator, and then you're in good shape. Any questions at all? Okay, let me give you the secret word. Let me double check, but I'm pretty sure. Yep. So the secret word of the day is, do it in purple and make it bigger. Sampling. I always try and put a major word that you may not just guess, especially if you didn't watch this. And remember that the central limit theorem is all about the sampling distribution, which means the distribution of all possible samples with that fixed sample size. Okay, so that's all I have to say for the webinar. I always like to make it a little more than an hour. We're there at 8:06 right now. So I'll always open it to questions. I want to remind you, by Thursday, make sure you do your initial post. This is an absolutely easy discussion post assignment, I promise. You don't have to do any math. And so there's no excuse for doing it late. But you do have the assignment by Sunday of the Chapter 7. And one of the reasons why I let you have an easy discussion assignment is so that because you can spend a lot of time on the exam, this online exam that you're taking. And that's purely online. That's not proctored. Proctored exam is in another 3 weeks. But the online exam is this week. And that's a very long set of questions that look very similar to the ones you've been doing on the assignments the last 4 weeks. So let me stop the share. And let me unmute you all because this is time for questions. So you should be talking. Doesn't let me unmute you, but you know how to unmute yourself. So are there any questions about anything?
You said the exams, just like the homework, we have like we can answer it as many times?
No, that's the one difference. For the exam, you only get one chance. Yeah, for the exam, you only get one chance, but it's very long. So be careful on that one. So really good question. I'm glad you asked. Yeah, you only get one chance. You get it wrong, it's wrong.
Okay.
Yeah. Otherwise, you'll be there for like tens of hours. Okay, but the assignments, you get to try as many times as you want. So what's a good way of practicing for the exam?
Doing the homework again?
Yeah, you do the homework in what's called review mode, which means you can try it again, and it doesn't affect your grade. So if you want to practice, you can do that.
How long do we have to take the exam this Sunday?
You have till Sunday at, I think, 11:59 is when it times out, p.m.
No, I mean, how long is the duration once we get started?
Oh, it's not timed.
It's not timed. Okay.
Yeah, so you really have until then. Yeah, so it's not a timed exam. You just do the problems, you work on them best you can, and when you're done and exhausted, you hit submit. Okay, other questions? But give yourself some hours because it's long. Any other questions? Okay. As always, if you don't have questions, we can say goodnight too. But if you do have questions, this is a good time to ask.
Good night.
Okay, good night. And also, Project 2 discussion forum is now online. I put Project 1 and took it off of the main area because now it's time to start thinking about Project 2. Next week, we'll talk about it.
Can I ask you a question regarding Project 2? So, like, say if you don't have a partner. So if you're looking for another group to work with, and say if you cannot join, how, because I noticed like with Project 1, there was someone that was looking for a partner towards the end.
Yeah,
it was
that
like
was
the day. I'm sorry?
That was a really bad idea for that person, by the way.
Correct. But if you're not able to, because, once the chemistry is already going with the group, it's kind of hard for someone to join in.
I don't think so because there's groups of 2, and the groups of 2 could add a third.
Yeah, but sometimes in the group of 2, they may not want to add a third.
Right,
so
but you can beg them, and I could beg them. When I ask, they almost always say yes.
Okay.
So ask me to ask if they don't, if you can't find anyone. If no one is opening up, then I'll be pushy.
Okay, so then let me ask you, just in case if it comes that you cannot join, what happens in that type of situation pertaining to if you can't find a partner, you already kind of started your own little project?
Then you lose.
How does that work?
You lose 15% of your grade.
50%?
15.
15%. Okay.
15 is pretty bad though.
Yeah,
If an average score is 90, that means you're getting a C, even with A work. Does that make sense?
Mm-hmm.
So don't get excited don't think only 15%. That's a big drop.
Right.
So
right, that's why I'm asking.
Yeah, do everything you can. If you don't have a partner, do everything you can to get yourself a partner. And if you, let me show you. What is it? That one, I believe. Yep. If you go to discussions, you will see Project 2 discussion. Right now, nobody has put anything in it because I just posted it up. And that's a good place to ask. Okay. You could also contact via email people, that type of thing too. And then post. So you definitely want a partner. And there's some weeks, so you got time, but don't wait till the end. There are some people that didn't have a partner and they want a partner because they learned their lesson on Project 1. Does that make sense?
Yeah. Yeah.
So there will be people that need partners. I haven't had a lot drop, and that's a good thing. I don't like to have a lot of students drop. I have a feeling that most students are going to pass this class. Okay, the vast majority, which is good. So there aren't a whole lot of people looking for a partner because their partner dropped, but there's some people that didn't have the chemistry in it, okay, or just didn't get a partner because I don't know why.
Okay. Thank you.
Okay, other questions?
What if wanted to come up there to take the midterm?
Great, great. So you come up here to take the midterm. What you need to do is you need to contact our library like a few days before. It's no problem, and it's free. Tahoe's beautiful, and they'll bring you into the testing center, hand you the test, and then you take your midterm.
All right.
Yep. Yeah, and the good news, in the winter time, there's an issue because we often have a lot of snow, and people can't drive up here. But usually in late May, you're in pretty good shape. Our roads don't usually close. It's a big problem in the winter, though. I'd say about a third of the time, people who plan to come up can't because of the snow. But spring, we're good.
Sounds good.
Yep, and then enjoy Tahoe while you're up here because it is absolutely beautiful.
Yeah, that was the plan.
Yeah. Any other questions? Okay, as always, if you don't have questions, we can say goodnight.
Thank you.
All right. Thank you.
All right, good night. And for those of you watching on the as an archive video, thank you for watching. Don't forget to post a secret word quiz and post on the Q&A discussion forum if you have any questions. I'll be happy to ask. And if you don't have a partner or want a new partner, post on the Project 2 discussion forum to ask to find a partner. And have a good night.